to see a lot of old friends in the room. Hello. I realized all of us have gone a lot grayer. Been a long time. So, excellent segue. I absolutely love the panel and hearing you all talk about the AI tsunami, right? So, my topic today is about looking at, what are those specific changes we expect to see in data centers. I'm from Schneider and my name is Shaheen. So, futuristic AI definitely needs futuristic data centers, but not all AI data centers are the same. There are two very distinct environments, and I heard Meeran talk about it. One is obviously training, where these large language models, large multimodal models, what excites me particularly, large action models which eventually will interact with robotics to change quality of life, these are developed, right? And these are developed in very intense environments, sometimes taking weeks and months for a run. And then there is the inference environment, which is where a compressed version of this training model is deployed at sites close to users, edge, where these models meet with you and me, users, right? And we will query or prompt these models to do some work for us. So the data centers where these are hosted and run are very different in nature from each other. Now, if we look at some Omdia data, what we see is that while there is definitely growth in AI that gets into training environments, we expect that there will be larger growth in where these servers are deployed for inference. So I want you to make very careful note of this slide, and there are two very key messages. This is Schneider's take, right? Obviously, we are going to look at about quadrupling of power that will be consumed by data centers running AI in the next 4 years. These statistics are from last year. So by 2028, it quadruples. However, I advise caution, not everything will be AI. We still will have traditional bills and traditional loads. So, while every event we go to and the industry and the investment dollar is so enthusiastic about AI, let's treat this in proportionality of where we will see it. So we expect by 2028, at most, AI will be deployed in about 20% of overall data center workloads. Now, what this means for us as an industry is, one, obviously there are tech giants who have very deep pockets, who have experimented with AI very aggressively over the last year. But enterprises, right, very likely will see these AI deployments not as dedicated AI-only purpose-built data centers, but actually as small upgrades in brownfield environments where we will need to modify existing infrastructure to also support certain AI applications. Another very interesting thing that I see will happen, especially 2025 onwards, is that this run of investments that we've seen, especially in the last 2 years around AI, right, the whole buzz around it, 2025 onwards, businesses will start questioning what is the return on these investments. Those will need to get proven. Now, the last piece, and this is again extremely interesting, all AI development will not be training. We expect that while today these training models running out of central large core data centers constitute about 95% of overall AI workloads, however, we expect that in about 4 years' time, half of these workloads will actually be at point of use, which is the inference at the edge. So what is it that makes AI data centers different, right? Especially in training environments, a traditional CPU cannot do the job needed. The reason for that is the compute and the memory share a path, and that creates something called a von Neumann bottleneck. The CPU slows down, it has to wait for data. So we need specialized servers, which, of course, we know all about graphic processing units. They have their origin in the gaming industry from nearly 20 years ago. These specialized servers definitely have GPUs. By the way, each of these GPUs has a network port. But they additionally also have application-specific chips, and they have data processing units which take away the networking load from the CPU and actually create what is called a data center fabric. So you need specialized servers definitely in training environments. Inference you could do with CPUs or you could do with GPUs, but you could use it much lightly, and I'll explain how in a minute. So what happens is these GPUs process data at terrific speed. They require high speed communication, they use accelerators, they do things in parallel. And this requires the ability to communicate very quickly with each other. So they use networking protocols like InfiniBand, which we are all, perhaps for those of us who've been around the high performance cluster kind of projects, have seen deployed before. Now this is extremely expensive technology. So the only way to manage this need for speed is to bunch all these servers together very closely, right, for meeting those high-speed communication needs. And that creates massive densification of power by having a lot of stuff packed into a small area. So generally, AI training, the servers run in what is called cluster. And these clusters have some very unique behaviors. First and foremost, most of these racks are deploying servers that run at practically 100% utilization all the time. Now this, for those of us who are old-timers from the data center industry, is a shift from the way we designed data centers previously, where we would assume diversity, and as we went upstream with infrastructure, we were able to correct and right-size the infrastructure overall. Now we no longer have that luxury. These training models are deploying clusters running at nameplate capacity on power. The second thing is, these in turn run at thermal design power, which means they are running extremely hot, which brings us to the need for liquid cooling that got discussed in the previous panel. I'm sure we'll have a lot of presentations during the day when we'll hear about the various options available there. But that again is a big difference from the way we designed data centers in the past. What is even more challenging is that we do not know what TDPs of the future will be. So when you're building a data center today to last you for the next 10 years, 15 years, you actually have to, yes, right? And we heard about that. We are piloting a plane as we are building it, right? Now something else that's very unusual is that these training models are capable of self-checking themselves at regular points of time. So they have checkpoints, and what that means is today, if you were to crash this cluster, either due to loss of power or loss of cooling, it can turn back on and restart from a very recent point of time with minimal loss or corruption, which again means the past concept that we had, that high availability is the driving need for large data centers. Tier 4, I mean, we at some point of time even heard of Tier 5. A training cluster core data center does not require high availability. Okay, so very unusual things which we are not used to. So now we are seeing that typically a 800 kilowatt data center, which may have been spread out across 150 racks, could be collapsed into an 8 rack environment. It comes with considerable challenge. So this is a typical data center. All of you are familiar with this architecture. Now what we have to do with AI workloads is we have to densify the IT systems, distributing very large quantum of power in very small spaces, and at the same time working with cooling solutions which are yet developing, nascent. Even manufacturers and OEMs are discovering the technologies as they build out projects. So let me pick out a few favorites from what happens with these changes. So if you look at racks themselves will need to change because they are going to host very heavy servers within them. They need to have higher static load capacity, higher dynamic load capacity. They need to be deeper because now you have a humongous amount of power delivered into one rack, and you also have a huge amount of network and cable infrastructure coming in because each GPU, as I said, has its own network port. You might have rear door heat exchangers. You may have manifolds at the back. So the rack itself is going to be looking very, very different in AI environments. I'm rushing through this. I mean, if this PowerPoint is accessible to you post the event, please do go through it. There's very rich content in here. Now, if you look at the mechanical side of things, I'll not dwell on this more because you will hear enough on this. But the kind of solutions that you have for these very, very hot, dense environments, liquid cooling is obviously one of them. Air-cooled works till about 20 kilowatts. 20 to 40 kilowatts you can go by with a mix of liquid and air. 40 kilowatts density and above, you have to go liquid. And bear in mind, at that point of time, you're not deploying liquid because it's greener and more sustainable, but because it's actually no option but to use that. By the way, on liquid, you will hear of so many permutations and combinations. You have grid to chip, you have chassis immersion, you have tub immersion. I mean, please work through these on your specific projects. I mean, I think each one of you will come up with unique solutions. Now, the electrical infrastructure again is going to undergo a very, very radical change. So you have to deliver massive amounts of power into very confined spaces. Your power distribution infrastructure potentially may be very constrained. So we are relatively lucky in India. We use 400 volt and 230 volt. But we may find that with this huge amount of power and high amount of current running in your data center, the infrastructure itself is going to run a lot hotter. It's going to be prone to a lot more failure. There is more risk of arc flash. So you need to design your electrical infrastructure very carefully to be able to address these challenges. Now, power we talked about in considerable, with considerable detail and passion, I think, in the last panel. We had this situation where we had a customer in a developed country in Asia, who's a tech giant, go to the electricity, board equivalent and say, this is my AI roadmap, and this is the quantum of power I need to get my AI infrastructure going. And after a week, the answer they got was, sure, we'll do this for you. We'll build this infrastructure for you. It'll take us 10 years. So this could potentially be the biggest constraint to overall deployment of AI. In India, we have an infrastructure that is aging, but I think it also creates opportunity because the upgrades we do could be such that they support these kind of power demands. So reconductoring to marginally augment power capacity is an option, but I think somewhere along the line, we may not really find these solutions coming to us from the distribution companies. Organizations will have to start looking at their own solutions for generating power either on-site or off-site, and having a lot more grid interaction between data centers and obviously the grid. Now, while this is power, and I trust everyone appreciates the difference between power and energy. If you look at a pipe, the pipe is the power infrastructure, and the water that flows through it is energy. Now think about energy needs of such data centers. I think as an industry, the time has come for us, especially in AI environments, to look beyond power usage effectiveness as an indication of energy efficiency. Because what happens is, if you're, for example, using liquid cooling, part PUV will be fabulous. Your fans are gone, you'll get a great data center as a system. In an AI environment, you'll have excellent PUEs. Why? Because the denominator is super high. But this does not indicate whether your data center is sustainable or not. So the strong suggestion I make to us as a community is that it's time to move beyond PUE and water usage effectiveness to actually looking at absolute energy consumption of your data center. That is the true indicator, and extrapolate that to your carbon footprint. I think that is what will be relevant going forward. Sujit, you talked about the fact that we need to start looking at AI as a tool to manage data centers better. Now, for deploying data centers that will support AI loads, it's also important to use the right tools, especially around, for example, intelligent single line diagrams, using digital twins to be able to, let's say, with minimal risk, do upgrades and modifications in your existing data center. These tools will help you actually ready yourself for those small deployments of AI clusters in brownfield environments. So finally, in conclusion, I want you to remember this. Not all AI loads are equal and have the same demands in a data center. So on the one hand, you have training environments where you are on very high density. These are typically hosting large and extra large models. These are deployed in clusters, and their resiliency and availability requirements are low. Right? So rather than spend on redundancy, spend on building the infrastructure capacity. However, on inference, the ranges are lower. You can scale horizontally like you did in traditional data centers. The name of the game with inference is customer experience. So you don't, for example, when you're querying, when you're prompting a model for some work you want it to do for you, you don't want to experience loss of service. So here, availability is still extremely important. Right? I mentioned you can scale it horizontally and design it for higher availability. For those of you interested in reading, there is an excellent executive brief created in collaboration with NVIDIA, where we have looked at 4 scenarios of data center build-outs for AI workloads. 1 is a greenfield scenario, and 3 are brownfield retrofit scenarios. Please do go through this. It's a super useful document. Excellent guidance will help. So that was my quick 20 minutes. I guess I've shot over time, but I'm here for the morning. I'd love to get your points of view, catch up with friends, and of course take questions. Thank you.